So in section 1.4, we're going to talk about other effective sampling methods. So again, in the last video, we spoke about randomly generating numbers, whether it was from the table of values with a random number generator or inside the calculator. So now we're going to talk about some other ways to get some random samples. So there's three different ways that we're going to talk about today. One is going to be a stratified sample. The other is going to be a systematic sample, and our third way is going to be to obtain a cluster sample. So a stratified sample is one obtained by separating the population into homogeneous, non-overlapping groups called strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous or similar in some way. So the groups are going to be linked by some common characteristic and they're non-overlapping. So I'm just going to write a couple notes on here to kind of clarify this a little bit. So groups are linked by a common characteristic and they are non-overlapping. Helps if I spell overlapping correctly. Okay, so a very quick example of this, we might take the freshman class and divide them boys, girls, two separate groups. They're common characteristic, they're grouped by girls, the other group is grouped by boys, and they're non-overlapping. In other words, you can't have one person that's in both groups. So maybe a group of boys and a group of girls would be an example. So here is another example of obtaining a stratified sample. So in 2008, the United States had 47 Republicans, 51 Democrats, and 2 independents. The president wants to have a luncheon with 4 Republicans, 4 Democrats, and 1 other. Obtain a stratified sample in order to select the members who will attend. To obtain the stratified sample, conduct a simple random sample within each group. That is, obtain a simple random sample of 4 Republicans from the 47, a simple random sample of the 4 Democrats from the 51, and a simple random sample of 1 other from the 100. Be sure to use a different seed for each stratum. So again, when you're looking at this, you're separating by groups. Your groups are Republicans, Democrats, and independents. So inside that group, you're not going to have a Republican that's also a Democrat. So they're non-overlapping. They're common characteristic, Democrat, Republican, independent. So once I have my Republicans, there's my 47. And now again, you could do a random number generator and pick out your 4 from there using one of the methods that we did yesterday. Then pick out 4 from the Democrats, okay? And it doesn't say 1 independent, it says 1 other. So then you're going to put all of your people back together, and then you're just going to obtain 1 random number. So that last person could be either a Republican, a Democrat, or an independent. Okay. If you have something called a systematic sample, a systematic sample is obtained by selecting every kth individual from the population. The first individual is selected at random between a number between your 1 and your k. So for a systematic sample, a quality control engineer wants to obtain a systematic sample of 25 bottles coming off a filling machine to verify the machine is working properly. Design a sampling technique that can be used to obtain a sample of 25 bottles. So here's what we can do. We can determine our population size N. We can determine our sample size N, and then we can go on from there. So let's, again, using that example above, we don't know what our full population size is. So let's say N was, we had 4,027 bottles. Okay, determine our sample size of N. We just got that before, it was 25. And now we want to compute n divided by n and round down to the nearest integer. Okay, it's always round down. It's not round to the closest. Okay, so I'm going to do 4,027 divided by 25. And that's going to give me my answer of 161.08, which means I am going to use, rounding down, 161. So I'm going to take a bottle, then I'm going to count 161 more, and then I'm going to pull that next bottle off, so on and so forth. So now you're going to randomly select a number between 1 and k. And again, our k is our top of our population here. So it's 4,027, and we're going to call that number P. You need 25, but I just want to make a point here. I'm going to start with a higher number just because I want you to know in general and in a different example when you'd have to stop. So your P, I would probably pick a number like around 100 and then keep adding 161 till you get 25 numbers. But let's just say that we picked our P to be 3,500. So I'm going to take that 3,500 and I'm going to add 161 to it. That's going to give me 3,661. Take that 3,661, add another 161 to it, and my next number would be 3,822. I'm going to add the 161 again, and I'm going to get 3,983. And then when I add 161 again, I'm going to get 4,144. That number is bigger than your population, so you wouldn't be able to pull that one. Okay, so that's how you kind of know when to stop, is when you get to the top of your population. Again, I don't have 25 numbers here. I had to have started earlier, but I really don't think you want to sit here and listen to me add 161 25 times to a certain number. And again, I just wanted to make the point of as to where you need to stop. So once you get to a number that's bigger than the population, you're done. Or once you get your 25, but... All right, so a cluster sample. A cluster sample is obtained by selecting all the individuals within a randomly selected collection or group of individuals. Okay, so this time there's going to be diversity in your groups. Okay, so let's just say I'm in a school. I actually think this is the example on the next slide if I'm not mistaken. But let's say you have a school and now you're going to just randomly select classes. So you're going to select 4 classrooms, 102, 103, 104. Okay. Inside those classes, you can have boys and girls. There's a mixture. You're not simplifying it in any other way. So there's your diversity within the group. And yeah, okay, a school administrator wants to obtain a sample of students in order to conduct a survey. She randomly selects 10 classes and administers the survey to all the students in the class. So again, in that class, you have boys, you have girls, you might have sophomores and freshmen, so you're not separating them in any other way. So you have that diversity within your group. So here's just kind of a picture of what your different types of sampling can look like. Again, this simple random sampling, this one up here, is like what we talked about yesterday. You're just taking your whole population and randomly pulling different people from it, or different items if you're talking about manufacturing. So that's what that would look like. For the stratified sample, again, you're taking your population and again, you're splitting them into boys and girls. And then from that, you are taking a group and a group from that. And from your systematic sampling, again, you're taking your entire population. And again, maybe you're pulling out every third person. So again, you're pulling out the second person might be your P. If you add 3 to that, you're going to get to 5, then 8, and then 11. And your cluster sample is when you're taking your entire population, but you're going to have diversity within your group. So again, you can kind of see these are clustered together. These are clustered together. These all look the same. These all look the same. And from that, you are pulling randomly people from there. And I will see you for, oh no, there's I think there's more examples. I'm lying. I totally am lying. Sorry. Can't get rid of me that quickly today. A convenient sample is one in which individuals are sampled, are easily obtained. Okay, and again, we talked about Yankee Stadium in that last example, that last video. Again, if I stand outside Yankee Stadium because I was at the game and then ask people who are Yankees fans, you use convenience. It's not a good surveying method. And again, I apologize that you're staring at the answer at the same time, but again, I can't really do anything about that with the program that I'm using. Okay, so a study was conducted at the university in Cairo, Egypt, to determine the relationship between road risk perception and pedestrian injuries. The sample was taken from a list of student IDs. Every 40th student was selected after starting with a randomly selected chosen number. So now we want to know, is that systematic, a cluster, or is it stratified? So again, it's systematic. Why? Because you're taking every 40th student, every Kth student. So that one is going to be your systematic one. Okay. In a study of health conditions of residents of a nursing home, in a study of the health condition of residents in nursing homes, a simple random sample of all nursing homes in the city of Wenzhou were taken. All residents of the randomly selected nursing homes are interviewed. So we need to decide what's going on there. So we have to decide, is there diversity in the group? Can they overlap, or is it non-overlapping? And again, there is diversity in a group because your nursing homes aren't grouped by female, male, or maybe you have a nursing home that's 75 and older and another one that's 85 and older. So since you have the diversity within the group and your groups can overlap, that means that this one is going to be cluster. Okay, so diversity in the groups and they can overlap. So for our next one, in a study of lung function, a simple random sample was taken from 3 groups of children. Children who live on a farm, children with intermediate farm exposure, and children with no farm exposure. Okay, and this one is going to be stratified because members are linked by a common characteristic. Okay, in your first group, the common characteristic is they live on a farm. The one was with intermediate farm exposure and then no farm exposure. So they're grouped by a common characteristic. I think you could probably hear. Sometimes when I put the pen on the iPad, it doesn't register. It's quite annoying. So then I have to go back and kind of fill in letters. So I apologize. So they're grouped by a common characteristic and they're non-overlapping. Okay, so non-overlapping, again, in this case, what does that mean? You can't have a child that both lives on the farm and doesn't live on the farm. So it's either one or the other. Okay, so you could also have something called multi-stage sampling. Okay, and in practice, most large-scale surveys obtain samples using a combination of techniques that were just presented. Okay, and as an example of multi-stage sampling, consider the Nielsen Media Research. Nielsen randomly selects households and monitors the television programs these households are watching through a people meter. The meter is an electronic box placed on each TV within the household. The people meter measures what program is being watched and who is watching it. Nielsen selects the households with the use of a 2-stage sampling process. Okay, stage 1. Using U.S. Census data, Nielsen divides the country into geographic areas, or strata. The strata are typically city blocks in urban areas and geographic regions in rural areas. About 6,000 strata are randomly selected. The next thing that Nielsen does is it sends representatives to the selected strata and lists the households within the strata. The households are then randomly selected through a simple random sample. And then Nielsen sells that information obtained to television stations and companies. And these results are used to help determine prices for commercials. So again, based on how people answer is going to be based on the price that they're going to charge for your commercials. Okay, and that is really how Nielsen does their sampling. Okay, and that will be it for this section.